Okay, number one, at 5 p.m., Brunhilde headed north at 40 kilometers per hour. 3 hours later, Ludwig headed south. So if we focus first of all on directions, one's going north, one's going south. It doesn't specify a starting point, so we're going to assume they start at the same spot. So starting point here, Brunhilde goes an unspecified distance north. Ludwig goes an unspecified distance south. Nothing tells me that they want the same distance, so we can't assume those to be equal to each other. But we do want to know when they'll be 450 miles or 480 kilometers apart. So we want the distance between the two at the end to be 480 kilometers. So looking at the picture, we can see however far Brunhilde traveled plus however far Ludwig traveled is going to be how far both of them together traveled. So Brunhilde's distance plus Ludwig's distance is going to equal 480. Priority one is that distance relationship. That's taken care of now. Next step, we make a rate time distance chart for these two characters. And we can see that she's going at 40 kilometers per hour. He is going at 50 kilometers per hour. And I can put kph here as my unit for rate. We don't know what time they traveled. It's going to be in hours, obviously, because that's kilometers per hour. That's going to be kilometers. Okay. What we do know is starting times, but we don't know ending times. So be careful with time on the clock. So 5 p.m. is when Brunhilde started. He started 3 hours later. That'd be 8 p.m. his starting time. And it says at what time will they be 480 kilometers apart. So we don't know their ending time. But what we can see is that since she left earlier than he did, her time is 3 hours more than his time. So we can either put him as t and her as t plus 3, or her as t and him as t minus 3. Take your pick. I'm going to go with Brunhilde being t and Ludwig being t minus 3. And that confuses some people sometimes because we can see 8 obviously is 3 bigger than 5, and we might think with Ludwig plus 3, but he's leaving later, his time of traveling is less. So that's why we have to figure that out. So we can see then, if we take Brunhilde's rate times Brunhilde's time, we're going to get 40t for Brunhilde's distance. And if we take Ludwig's rate times Ludwig's time, which is a binomial we have to distribute, we're going to get Ludwig's distance of 50t minus 150. That equals d sub L. These two objects have to be created from these 4 objects. You don't want to put, like, we see a distance 480. Some people want to put 480 in here. 480 is in the picture to create this. Our job is to get these expressions to represent these two distances. So, Brunhilde's distance of 40t added to Ludwig's distance of 50t minus 150 is going to equal 480. So to solve it, I'm going to move the 150 over. It becomes positive when I move it. That gives me 90t on the left is equal to 630 on the right. 630. Dividing by 90 gets me t equals 7 hours. Okay, the last thing I need to do is answer the question. All t represents is how much time Brunhilde took. T minus 3 then will be 4. That's how long Ludwig took. So we knew how many hours Brunhilde traveled and how many hours Ludwig traveled. But the question says at what time. They want to know the time on the clock. So we take, since t represents Brunhilde's time, we take Brunhilde's starting time, which is 5 p.m. We add 7 hours to that. 5 p.m. plus 7 hours makes 12 o'clock, midnight. And for the sake of having an a.m. or p.m., midnight is 12 a.m., noon will be 12 p.m. I could have done the same thing with Ludwig's time, 4 hours. He started at 8 p.m. 8 p.m. plus 4 hours also is 12 midnight. So there you go. If you wanted to be sure, sometimes people mess up with a.m. and p.m. on that. If you just put midnight for midnight, noon for noon, that'd be fine if 12 happens to be the answer on the test also. Number 2, Billy ran to town at 8 kilometers per hour, then walked back home at 6 kilometers per hour. So, this person's running to town, then walking back home. I'm assuming the town and the home are in the same place and all the way through the problem. So, here's the house. Billy ran to town. And then Billy walked back home. So the distance going and the distance returning, you know, pick whatever variables you want. I'm picking G for going, and R for returning. Maybe R for running and W for walking. That might even be better. Let's go with that. So Billy ran to town, walked back. So we can see from the picture the distance running is equal to the distance walking. That's priority one taken care of. My categories I've chosen are running and walking. We've got rate, time, and distance to worry about. I want to worry about rates and times from the picture, or from the problem. Billy ran to town at 8 kilometers per hour, so 8 kilometers per hour. That means this is hours, this is kilometers. Walk back home 6 kilometers per hour. Then they tell us the round trip took 7 hours. This quite often happens in these problems where they tell you not how much this time is or how much time that is, but together they're 7 hours. So one of the times is t, the other is what's left over, which is 7 minus t. For example, 2 hours, 7 minus 2 is 5. 2 and 5 make 7. 3 hours, 7 minus 3 is 4. 4 and 3 make 7 hours. So if you set it up that way, total minus t, that's going to be the setup. That's a binomial, so distributive property is necessary. 8 times t is 8t for the distance running. 6 times 7 minus t is 42 minus 6t, distance walking. We've already established those distances should be equal to each other. So the running distance and the walking distance are set equal. 8t is equal to 42 minus 6t. Move the 6t over. It's minus, so it becomes plus, so we get 14t is equal to 42. So t is equal to 3 hours. Again, t represents a time in hours, so that's how we get the correct unit on that. The running time is 3 hours, the walking time, 7 minus 3 would be 4 hours. The question specifically states, how far was it to town? The question they want to know is that, d sub r, and d sub r is 8t. So, once I've established what t equals, 3 hours, I take 8 times 3, because that's what that says, and that gets me 24 kilometers. Number 3, Marfugi had $98.25 in quarters and half dollars. If he had 245 coins in all, how many of each type did he have? So, we have quarters and half dollars. So if we start off with number of coins, we're going to say Marfugi had Q quarters and H half dollars. That just is a number of things. So it could be 17 quarters, could be 238 coins, 228 coins, whatever it is. All right. So quarters, half dollars, Q and H represent how many we have. And then for value, with coins I like to be in cents. So every quarter is worth 25 cents. We have Q of them, so 25Q is the value of all the quarters. Every half dollar is worth 50 cents. We have H of them, so 50 times H is the value of the half dollars. And then we just take a look at the facts to create equations. So he had 245 coins. That represents a number of things. We use the number variables. Q plus H is equal to 245. The other fact, it says that he had $98.25. $98.25 is the same as 9,825 cents. So make sure the value of currency matches to create the facts. The value variables, these variables should add up to the total value of the money. So 25Q plus 50H should equal 9,825. Just looking at that equation, divides by 25, divides by 25, divides by 25. We know that because the last 2 digits of each number is a number that divides by 25. I would do that. So I would take that equation there, divide everything by 25. That's going to give me Q plus 2H equals, and 9,825 divided by 25 comes out to 393. This purple equation is perfectly right, but the black equation is much more easy to deal with. So at this point, I'm looking at my system of equations that I have, 2 variables and 2 equations. Q, H equals number. It's set up best for elimination. I'm going to eliminate Q because that's Q, that's Q. All I have to do is change the signs. I'm going to make this one negative. So what we end up with is, this stays q plus h equals 245. The black equation transforms to negative q minus 2h equals negative 393. Q minus q cancels. H minus 2h is negative 1h. 245 minus 393 is negative 148. Okay, check my math here to be sure. 245 minus 393 comes out to negative 148. That's exactly right. So if h equals negative 148, that means negative h equals that, positive h equals positive 148, and that's $half. Okay. The other thing we need to know is quarters. To get quarters, I'm going to put 148 right here. So I got to move 148 over to the other side. So 245 minus 148, which is 97. Yep, 97. So q is equal to 97 quarters. Alright, so number of coins, value of coins, pretty basic coin problem there. Larger than normal answers, but that's not beyond your abilities with calculators. Number 4, p squared equals 169. So p is equal to plus or minus 13. Just take the square root of both sides. Do not forget the plus or minus sign. There's nothing else to do on that problem. So it'll be that easy on the regular test too. Get that one right. Number 5, simplify. We have a division. All right, so what I'm going to do is I'm going to factor each of these things. So that factors, and this factors, and this factors, and this factors. But I also want to flip this fraction over because of the division. I want to change it into a multiplication problem. So if I go ahead and create the structure that I'm looking for, fraction times fraction, I'm going to factor this on top, positive 5 and negative 1, 5 minus 1, so x plus 5 times x minus 1. Binomial, greatest common factor of x, take x out, x minus 12 is left over. I'm factoring the red on the bottom, positive 2 and negative 1, 2 minus 1. So x plus 2, x minus 1. And the black one's going to go on the top, common factor of x, take that out, x plus 2 is left over. So the type of factoring, you got your trinomial, the factoring chart if you need to use it, but the guess and check technique to factor those. Greatest common factor on the binomials, kind of expect the same type of factoring to happen on the test. Then we're simply looking for common factors on top and bottom. They're exactly the same, they can be canceled. So this x minus 1 matches that x minus 1, so the x minus 1's cancel. This x matches that x, the x's cancel. This x plus 2 matches that x plus 2, x plus 2's cancel. What's left is an x plus 5 and an x minus 12 that aren't the same. And there's your answer. I will make it so everything cancels except for one thing and one thing. So expect that. If it doesn't happen, chances are you factored improperly. Maybe you forgot to change division and multiplication, that kind of stuff. So you should be left with a single object on top, single object on bottom. No multiplying necessary in the final step. Number 6, solving a quadratic equation. First thing I want to do is get everything equals 0. I like x squared positive, so I'm going to move the 72 over to the right. So 0 is going to be left on the left-hand side. I'm going to make this x squared plus 18x plus 72. And be careful that the sign does change, becomes positive. Now this time I'm trying to factor this, and this is a little bit larger numbers. Maybe it's not as easy to see the breakdown on this one. So if you're having trouble with that, you want factors of 72, whose sum is positive 18. Look for two positive numbers, and if you don't know right off the bat what those two positive numbers are, just start with 1. 1 times 72 isn't right. 2 times 36, also 72, still isn't right. 3 times 24, still multiplies to make 72, still isn't right. 4 times 18, still 72, still isn't right. 5 doesn't go into 72. 6 times 12 is 72. 6 plus 12 is 18. There's your correct pair of numbers. So you find your correct pair of numbers, and that's how this is going to factor. So x plus 6 times x plus 12 is equal to 0. And then as far as the solving part is concerned, once we got it factored, solve means that we take each factor. So x plus 6, set it equal to 0. X plus 12, set it equal to 0. So we simply solve both of those equations. So x plus 6 equals 0. X plus 12 equals 0. And all we have to do to solve those is move the number to the other side and change the sign. So move that over, change the sign, that gets me x equals -6. Move the 12 over, change the sign, that gets me x equals -12. Okay, so it should be of similar nature. It'll be a factorable trinomial. Once you get factored form, each factor is equal to 0. Solve those to get the final answer. Number 7 is a binomial. There's no x term. There's only x squared and a constant. Couple ways to do this. Here's way number 1. 64x squared minus 121 equals 0. Descending order, minus in the middle, take your pick. Perfect square, 8 times x times 8x times 8x. This is 11 times 11 being subtracted. So, difference of squares factors as square root of the first in front, square root of the second in back, 1 plus 1 minus equals 0. Once again, factored form equals 0. That gets me immediately to either factor 1 equals 0 or factor 2 equals 0. So if we go with factor 1, that's 8x plus 11 equals 0. If we go with factor 2, that's 8x minus 11 equals 0. In this case, to solve, I got 2 steps. I got to move the number over, minus 11. That gives me 8x equals -11. Then we divide by 8, x equals -11/8. Over here, plus 11 makes 8x equals +11. Divide by 8, I get x equals +11/8. Those are the correct answers. Option 2. That's done. So here's option 2. We'll do this one in red. All right. There's no x term, so what I can do is keep my x squared term on the one side, move my constant to the other side, divide by 64 to get rid of the coefficient. And if x squared equals a number, that means x equals plus or minus the square root of this number. The square root of 121 is 11, the square root of 64 is 8. Same answers, plus or minus 11/8, plus or minus 11/8. I don't care how you do it, just get the right answer. Both techniques are valid and work every time. Number 8, long division. Okay. First thing we want to do is write it as a good long division problem. So x minus 4 goes outside, that's what we're dividing by, and what goes inside is x cubed minus 3x squared plus 1. I'm going to put a plus 0x because there's no x term to be seen up there. We account for that possibility of it showing up, so we put that 0x there just in case it does show up. And the process is what it has been, and we hopefully have been practicing this process. We divide first by first to get the answer. So x cubed divided by x makes x squared. Whatever answer we get, we multiply by both pieces. So we divide only by the one thing, we multiply answer times both things. X squared times x makes x cubed. X squared times -4 makes -4x squared. Then we subtract. Subtracting is changing signs. X cubed becomes negative, 4x becomes positive. X cubed minus x cubed cancels. -3 plus 4 makes positive 1x squared. Then you bring everything else down, and you do it again. First thing divided by first thing. X squared divided by x is positive x, so put plus x. If it was negative, we'd put a minus x. Positive x times both things is going to be positive x squared, and it's going to give me minus 4x. Subtraction is changing signs. X squared becomes negative, 4x becomes positive. X squared minus x squared cancels. 0 plus 4 makes positive 4x, and that's plus 1. Once again, divide first by first. 4x divided by x is going to be positive 4, so plus 4. 4 times x minus 4 is 4x minus 16. Subtraction is changing signs. 4x becomes negative, 16 becomes positive. 4x minus 4x cancels. 1 plus 16 is 17. Once you run out of x's, you're done dividing. The remainder is positive, so I put a plus sign. And then we take the remainder value, 17, over the divisor x minus 4. It should be of similar nature on the test. Again, the most common mistake people make is they don't change both signs. They change this but not that. So be careful both signs change. The other thing that sometimes people leave pluses and minuses out up there, especially this one. Make sure the remainder is being added or subtracted based on its sign. Just check that you do good work. You know, these are different, so I subtracted. Those are the same, so I added. Those are the same, so I added. Just basically keeping your rules of adding sign numbers properly done. Number 9, simplify. We're multiplying a bunch of radicals together. The outside numbers are going to multiply together to make an outside number. So 3 times 5 is 15 times 5 is 75. And then for the square roots, instead of multiplying the square root stuff together, I'm just going to factor it the rest of the way. So what I have is 3, 2, and 6. 3 is 3, 2 is 2, both prime. 6 is 3 times 2. Okay, you want to break down every number into its prime factorization. 3 already is prime, 2 already is prime, 6 breaks down to 3 times 2. And then we're looking for any pair of numbers that's inside that can be pulled outside. So I got a pair of 3's, so I strike the 3's out. One pair of 3's allows me to pull 1 3 outside. And then I've got a pair of 2's. One pair of 2's gets to pull 2 outside. Nothing else is paired up. In fact, nothing else is in there. So what's left is just all this stuff's being multiplied together. 2 times 3 is 6 times 75 is 450. Square root of nothing, so just the square root goes away. If there was any number left in there, square root of that number would be left on the answer. But in that case, everything goes away, so the square root just disappears. Number 10. Solving a system of equations. We've already done one of these with the coin problem earlier, but this one is a little bit more complicated to do elimination. I want to get rid of the y maybe because the signs are different. If I take the bottom equation times positive 5, that makes negative 15y. Take the top equation times positive 3, that makes positive 15y. The whole idea of elimination is if I just focus on the one I want to get rid of, I want those to be opposite objects, so I make that happen. So if I go ahead and do the multiplication, top 3 times 3x is 9x, 3 times 5y is plus 15y, 3 times 21 is 63. The bottom equation, 5 times 2x is positive 10x, 5 times negative 3y is negative 15y, 5 times negative 5 is negative 25. So now, I took the original system of equations, made the new system of equations with the desired effect right here of having opposites. So now if I add the equations together, which is our end result every time we use elimination, we eventually add the equations together. 9x and 10x makes 19x because that's what they add up to. 15 minus 15 cancels, so those just go away. And 63 minus 25 equals 38 because we subtract because the signs are different. 63 is bigger, so it's positive 38. We know 19x equals 38. We divide by 19. That gives me x equals 2. My job on these problems is always to get an ordered pair, x comma y. All I've found so far is x. To find y, I've got to go back to the original problem. I'm going to go right here, this one. And I'm going to use that equation to find y. So what I know is what x equals 2. So I'm going to take that fact and say instead of 3x, 3 times 2 plus 5y, I don't know what y equals yet, equals 21. 3 times 2 is 6. Minus 6 moves over here, so 5y is equal to 15. Divide by 5, we get y equals 3. So x equals 2, y equals 3, ordered pair 2, 3 for a final answer. Number 11, solving a rational equation. We've had fractions in this equation. First thing I'm going to do is multiply the entire equation times the least common denominator of 4. Now be careful, since there are binomial numerators. I'm going to show you here what I'd expect to do at this point. As you get more comfortable with these, there's some corners you can cut. But right now, just to be safe, I'm going to divide 4 by 2 to get 2. That's supposed to multiply by the top k plus 1. Instead of multiplying it, I'm just going to write 2 parentheses k plus 1. 4 divided by 4 is 1, so I'm going to get minus 1 times the top k minus 3. I'm on my k prettier here. And then 4 divided by 2 is 2 times 1 is 2. So you divide, multiply the result times the top. When the tops are more than one object, just put top, or the result of the quotient times the top in parentheses. Now, the reason I want to be really careful about this is not for this one. This is pretty straightforward. 2 times k is 2k. 2 times 1 is plus 2. What we want to be careful of is this one. This is a negative 1 in front of this. It's going to distribute through here. Negative 1 times k makes negative 1k, which everybody would have gotten. But negative 1 and negative 3 make positive 3. This is a very commonly missed sign in this problem. So be careful with binomial numerators that you write it like this first and then distribute correctly with the correct sign when you're doing your multiplication. And that equals 2. Next step, combine like terms. 2k minus 1k makes k. 2 plus 3 is equal to 5. That's supposed to equal 2. And if k plus 5 equals 2, we move the 5 over and get k is equal to negative 3. Number 12, solve. First thing I notice is a zero power here. So the first thing I would do before I do anything else, I just would copy the problem back down. M minus 1 parentheses 3m minus 1 equals 3m minus 9. I would just immediately make that m to the 0 equal to 1. The minus sign is not being raised to the 0 power, so it stays minus. And this is being subtracted, so it's not m times that stuff. It's just negative 1 times this stuff. This m is subtraction. Same issue here as the last problem. We had a minus 1 that's being distributed through here. Make sure that the sign change occurs properly. So m stays m. Negative 1 times 3m is negative 3m. Negative 1 times negative 1 is positive 1. That's going to equal 3m minus 9. Next thing, combine like terms on the left-hand side. That's 1m minus 3m makes negative 2m plus 1 is equal to 3m minus 9. I'm going to move the 2m over to the right. I'll move the minus 9 over to the left. 2m becomes positive, 9 becomes positive. Both signs changing as you move them. 1 plus 9 equals 10. 3m plus 2m is 5m. We divide, we get m equals 2. Always divide by the number in front of the letter. 10 divided by 5 equals 2. 13, we're supposed to simplify. It's got a bunch of stuff going on here. First thing I notice is this whole thing's being multiplied by this whole thing. This whole thing's being multiplied by this whole thing. This subtraction is going to be happening within the bracket. So I need to evaluate, then multiply. I need to multiply, then I need to add or subtract. The whole time that's happening, this is outside, so I'm going to leave it outside. I'll just keep on calling it that for right now. And that's also outside, but it's subtracted, so I can just go ahead and maybe evaluate that right away. The cube root of a negative number is going to be a negative number, and 5 times 5 times 5 is 25. So that's minus negative 5 is what ends up happening there. And again, that is a subtraction symbol. So when I go next step down, minus 5 is plus 5. I have to evaluate all this stuff first before I add 5 at the very end. So if I continue on here, 3 is squared, the minus sign isn't. That's negative 9 minus 4 is negative 13. 5 is squared, the minus sign isn't. 5 squared is 25, so negative 25 minus 6 is negative 31. Negative 50 times negative 8 is positive 400, but that positive 400 is being subtracted. 13 times 31 is equal to 403, and since they're the same sign, we get a positive 403, so that's 403 minus 400. At this point, my negative 2 to the 0 is negative 1. Again, the 2 is to the 0 power, the minus sign isn't. 403 minus 400 equals 3. So that gets me to negative 1 times 3 plus 5, negative 3 plus 5, which equals positive 2. Okay, it's all about the order of operations there. Don't go outside the order of operations. Make sure you go in the correct order. A lot of big numbers happen in it, but small answer, I would expect similar results on the test. Number 14, find the area of the shaded portion of the parallelogram. Okay, a parallelogram's area formula is base times perpendicular height. This is the base, this is the perpendicular height. So if I wanted to find the area of the parallelogram, ignoring the unshaded stuff, I'm simply going to do 35 times 25. Which is 875. So 875 is the area of the entire shape, ignoring the unshaded part. So if it was just all shaded in, that would be the answer, 875. But we do have two circles. The area formula for a circle is pi times the radius squared. So in the case of our two circles here, I'm going to get area of the circle is going to be pi times 16, which is 50.24. If I use 3.14 for pi, that's the area of one circle. So this one is 50.24. This is the same size circle. This is also 50.24. So we have two total circles, both of which are 50.24. If I add those together, I get 100.48. We subtract the unshaded from the entire shape to get the shaded part. We have to borrow to make that happen. Make that a 4, make this a 10, reduce that to a 9, make that a 10. 10 minus 8 is 2, 9 minus 4 is 5, 4 minus 0 is 4, 7 minus 0 is 7, and 8 minus 1 is 7. So 774.52, unit of length is inches, so inches squared. And our last one. The base of a right solid 27 feet high is shown. Find the surface area of the right solid. Okay, so surface area is 2b plus ph. B is equal to the area of the base, P is the perimeter of the base, H is the height of the solid. So let's start here. A base of the right solid 27 feet high. The right solid is 27 feet high, so I already know the height of the solid. What I need to do to work this problem out is figure out the area of this whole thing, the perimeter of this whole thing. Let's start with perimeter, it's easier. I need to know the length of this piece. It's a semicircle. The circumference of a whole circle is 2 pi r. We have half a circle, so the circumference of half circle is pi r. So the radius is 5. 5 times pi is going to be the length of that piece. 5 pi is the same as 15.70. So to find perimeter, I simply have to add 26 plus 24 plus 15.70. That'd be 50 plus that makes 65.70. As far as area is concerned, I need to find the area of this triangle and add it to the area of the semicircle. Alright, so if you do the triangle first, the base is 24, the height is right here, which it doesn't identify the height, but that's a radius down 5, that's a radius up 5 for a total of 10. So the height is 10, the base is 24, the area of the triangle is going to be 24 times 10 divided by 2. 12 times 10 is 120. As far as the semicircle is concerned, the area of the semicircle is going to be pi times the radius squared. Pi times 25 in this case. That's the whole circle. We only have half a circle, so we divide that by 2. And that gets me, I think, 39.25. Let's just make sure. 25 times 3.14 divided by 2. 39.25. Perfect. So the area of the triangle is 120, the area of the semicircle 39.25, the area of the whole shape is simply the sum of those two because both shapes together make the figure up. So 120 plus 39.25 makes 159.25 square feet. Okay, so that's my priority when I'm trying to do surface area. Find out these three numbers before you start applying the formula. So now once I know those three numbers, B is 159.25, it goes right there. P is 65.70, it goes right there. And H is 27, it goes right there. So my surface area is going to be 2 times 159.25 plus 65.70 times 27. Alright, so 2 times 159.25 comes out to 318.5. And 65.70 times 27 comes out to 1773.9. So to get the total surface area, I simply add these two numbers together. Multiply, multiply, then add. Order of operations again. So 318.5 plus 1773.9 comes out to 2092.4. And that's going to be square feet. You want to know where the square feet comes from? That's square feet there. This is feet, and this is feet. 2 times square feet, that keeps that square feet. Feet times feet makes square feet. So square feet added, keep it as a square foot. That's where it comes from. But just know surface area is going to be in square units. Dimensions are in feet for this problem.